Welcome to my Kcse Mathematics Revision channel. Teacher James Marita. We are looking at the past Kcse questions on differentiation, and today we are looking at questions that was set in the year 2019, section P, which was carrying 10 marks. So in Kcse 2019, we have been given the question of a curve, which was equivalent to the x raised to the power 3 plus x raised to power 2 minus x minus 1. So from this equation here, we are supposed to find the stationary points of the curve. How do you get the stationary points of the curve? To get the stationary points of the curve, first of all, you need to do a differentiation. You need to differentiate the curve, the equation of the curve given. From there, you find after differentiating that one, then you understand that at the stationary point of the stationary, when a particle is at the stationary point, the gradient function, that is dy dx, is equivalent to 0. That one will give you a quadratic equation whereby you will either use a complete square method, or you can use the PSF, that is the product sum and factor method, or you can use the quadratic formula, and that one you will get the two values of x. After getting the two values of x, you go back to the equation of a curve. You substitute the first value of x, it will give you the first value of y. So in that point you will get the first turning point. Then you go back again, you substitute the second value of x, because you will be getting two values of x. That one will give you the second value of y, and that one will give you the second turning point of the curve. So to start, you are supposed to get the dy dx. So dy dx from of this curve, so we have dy, then we have dx, which is equivalent to b. 3 times 1 is giving us 3x, then we have squared. Y squared, because you will have this 3 minus 1, it becomes a square. Then we have plus 2 times 1 is giving us 2, then we have minus 1 there. It remains like we have that one as x, minus this one is 1 times 1 is just 1. Then this is 0, and any number raised to 0 is 1. And of course, the derivative of a constant number is equivalent to 0. So that's our dy dx. So after getting our dy dx, you understand that at the stationary point of the curve, the dy dx is equivalent to 0. So we need to get our quadratic equation. That means that 3x squared plus 2 of x minus 1, this is equivalent to 0, because at the stationary point, when the particle is at the stationary point of the curve, that gradient function dy dx is equivalent to 0. So from here we have our quadratic equation, whereby we either use a complete square method to get the value of x, or you can use the quadratic formula to get the value of x, or you can use the PSF formula, that is the product sum and factor method formula. So for example here, if we can use that PSF formula, we have PSF formula, we have the product is equals to P, it is 3 times this one is giving us negative 3. Then we have our sum is equals to P, this one which is 2, and the factors. Factors are the two numbers which will give us a sum of positive 2, and those two factors, when we find the product, is giving us a negative 3. So the factors are 3x minus x. So this one here it is 3x minus x. So 3x times x is giving us a positive 3x squared. 3x minus x, we have positive 2. So those are the factors. So we have 3x squared. Sasa badala ya kuandika hapa 2x, we replace by the two factors. So we start with a positive 3x here, then minus x, because these two will give us positive 2, and then minus 1, then this one here is equivalent to 0. So if we can group this one into two parts, we group into like this one. We factor out 3x into, we have this is x now plus 1 minus 1 into x plus 1, this one is equivalent, that one is equivalent to 0. So from here, we either say that 3x minus 1 is equals to 0 from this and this one here. So from here, the value of x is equals to be 1 all over 3. Or you can say that x plus 1 here is equals to 0. So from here, we can conclude that the value of x is equals to be negative 1. So from our quadratic equation, we have found that the two values of x is equivalent to be a third and x is equivalent to be negative 1. So to get the turning point, at x is equals to be a third, what is the value of y? So x is equals to be 1 all over 3. It means that y is equals to be 1 all over 3 because we are substituting here. This one is raised to power 3 plus 1 all over 3. This one here is a square minus 1 over 3 and then minus 1. So after doing that one, you will get that the value of x at x is equals to be a third is giving us negative 32 over 27. So the value of y here is equals to be negative 22 all over, we have that one is negative 32 all over 27. So the first turning point of the curve, x is equivalent to be a third, y is equivalent to negative 32 all over 7, correct? When the value of x is equals to be negative 1, and x is equals to be negative 1, y is equals to be negative 1 raised to power 3, and then we have negative 1 squared minus negative 1 minus 1. So if you can do that substitution, you will get that at x is equals to be 1, the value of y is equals to be 0. So this one here, the value of y is equals to be 0. So the second turning point of the curve, x is equals to be negative 1, the value of y is equals to be 0. So this is the first turning point. The first turning point is here, whereby we have when the value of x is at that, y is equals to be 32 over 7. When the value of y is negative, when the value of x is negative 1, y is equals to be 0. So this one gives the first turning point, and then we have the second turning point of the curve. Then we are supposed to find the nature of the stationary point of the curve. We have to get the nature of the stationary points of the curve. Hapa, there are two methods of getting the nature of the stationary points of the curve. There is a way you can draw a table, you use the values of x, you draw a table, you use the value of x, then you can represent the diagram. You use the value of x, you use the gradient function, that is dy dx, and then you can represent the diagram. Method number 2, you can also have the second derivative. That means you will differentiate the second derivative. You know the first derivative is this one. So if we can go ahead and differentiate, this one is giving us our second derivative. So the second derivative of this one is equivalent to what? Our second derivative of this, we have d2 over y, and then we have dx2, this one equals to b. The second derivative of that one is giving us 2 over this one, 2 times 3 is giving us 6x of that. Then plus, we have this is 1 times 2 is giving us 2. And since here, the value of the power of x is equivalent to 1, 1 minus 1 is equivalent to 0, and any number raised to 0 is equivalent to 1, and this one now remains like that. So after getting that now, we can substitute. We either use when the value of x, where the value of x is equals to be, negative 4. So because we have the two values of x here, we have the two, when the value of x is equals to be negative 4, what can we have here? So when the value of that value of x is equivalent to be negative 4, when the value of x is equivalent to be negative 1, because we have two values of x, the value of x is equals to be negative 1, the value of x is equivalent to -1, and again the value of x is equivalent to p at that. So at x is equals to p, so we can say here at x is equals to p, -1, we can substitute there, and then we see what we can get. So if we substitute here, we have 6, the value of x is -1, so -1 here, and then +2, and this one is giving us +4. You check that one because you can get that one. You can get that one as a positive. Once you get this one as a positive, then we want to identify within among these 2 points here where x is equals to p -1. When x is equals to p -1, the gradient function here is a positive. The positive gradient, it means that the point is minimum. So understand here, when we have a positive gradient, the point here is, we call this one as a minimum point. When we have a negative gradient, it means here that point is maximum. So we have picked 1.1, the second stationary point where we have x is equivalent to -1. The gradient function after the second derivative is giving us +4. It means that this point, the point -1, 0, this is a point of minimum. So we have this is a point of minimum, that is the nature of that point. Then the second one, we can substitute when the value of x is equivalent to p at that. So at x is equivalent to p at that, x is equivalent to p, 1/3. Our dy, the second derivative y, then we have the second derivative of x is equals to p6. Then we have this one here is a third. Then we plus this one is a third, and then plus a third plus 2. Then you will get that third one is giving us -4. So this one is giving us -4. Once it's giving us -4, what you can conclude? We conclude that this point, which is negative, which is a third, -32 all over 7, because it's giving us a negative here. So this one here we can conclude this one is a maximum. So this one here, it is a maximum point. So that is a question of Kcse 2019, whereby you were supposed to find the stationary points of the curve. Getting the stationary points of the curve, first of all, you need to have the gradient function, that is a derivative. After differentiating that one, it will give you the two values of x. You substitute the first value of x in the original equation, it will give you the first value of y, and that one will give you the first turning point of the curve. Then again you use the second value of x, you substitute in that the equation of the curve, it will give you the second value of y, which will give you now the second turning point of the curve. And of course, when you want to get the nature of the turning point of the curve, there are two methods where you can use a table and the values of x. You use a table and the values of x, and you represent a diagram. When you require, if you require to use a table here to get the nature of the stationary points, then understand that the y coordinates cannot be used to determine the nature of the stationary points of the curve. Then the second method, which is the easiest one here, with this way you can use the second derivative of the gradient function. You substitute the value of x, you substitute the value of y, the value of the second value of the first value of y, and the first value of x, and the first value of y. When you get the values, that gradient is giving you a negative, it means that point is at the minimum point. When you get the gradient is giving you a negative value, it means that point is giving you a maximum turning point. Don't forget to subscribe to my channel, watch and share.